Namaste. I am Dr. Nanjan Swami GS, Assistant Professor, Department of Chemistry, JSS Academy of Technical Education, Noida. This lecture contains discussion of infrared spectroscopy. Introduction. Infrared spectroscopy. Before that, spectroscopy can be defined as the interaction between matter and light. Means the infrared spectroscopy deals with the infrared region of electromagnetic spectrum, that is light having longer wavelength and lower frequency than visible light. Infrared spectroscopy generally refers to the analysis of interaction of the molecule with infrared light. When the infrared light is passed through a sample, some of the frequency radiation are transmitted through the sample without being observed. Some of the radiation frequency it may be observed. Based on that, the plots of percentage transmittance against wave number is called IR spectrum. We can observe from the figure x-axis is wave number, unit is centimeter inverse, y-axis percentage transmittance. The peaks are present in that graph, which is responsible for the percentage of transmittance, the percentage of transmitted radiation when the IR radiation is passed through the sample. And also the plot of percentage absorbance against wave number is also known as IR spectrum. In that x-axis we can observe wave number centimeter. The range means region 4000 centimeter to 400 means infrared spectroscopic range is in between 4000 centimeter to 400 centimeter wave number. Infrared spectroscopy is one of the powerful technique. It is used to determine or identification of the molecular structure. Means structural analysis. We can analyze the structural analysis. Means this infrared spectroscopy is having various quantitative application within analytical chemistry. And also IR spectroscopy is widely used to determine the functional group which are present in the organic molecule, and also to study the molecular interaction or atomic interaction in a material or sample. We can easily investigate by using this technique. In that, for the determination of this functional group, molecular interaction, or identification of molecular structure, the infrared radiation of electromagnetic radiation which are used in the infrared spectroscopy. That is, the infrared region is very important. Means there are three well-defined infrared region. The first one is near infrared region. The range is in between 12,000 centimeter to 400 centimeter. This near infrared region, it consists of overtones and it is very useful for the quantitative analysis. In this region, it will observe very poor absorption, means transmittance is more. The second one is mid-infrared region. The range is in between 4000 to 400 centimeter inverse. This is one of the range mid-infrared region. It provides a structural information of the organic molecule. Means this range only we are using, means the organic chemist using to determine or to identification of the molecular structure, means the identification of the molecular structure. The third one is far infrared region. The range is in between 400 centimeter to 33 centimeter inverse. This range, it has been used less when compared to other ranges such as near infrared range and mid infrared region. It has been used with the inorganic compounds, means to determine or to analyze or to investigate the atoms or metallic bonds or molecular skeleton or molecular complex in inorganic compounds. Next slide. We can observe here, means the near infrared region, mid infrared and far infrared. In the middle of the range, in that x-axis 4000 centimeter to 400 centimeter wave number. In the mid infrared region, using this region we can analyze the range. In the mid infrared region, we can observe the number of vibration frequencies, means we can observe the stretching vibrations and bending vibrations of some diatomic molecules. Means that the infrared spectroscopy is one of the most useful method to perform the structural analysis. Means the mid infrared region is more infrared region provides the more information about to determine or to analyze the molecular structure. In that mid infrared region, there are two type of region. The first one is the functional group region. The second one is fingerprint region. The functional group region, the range is in between 4000 centimeter inverse to 1450 centimeter. The peaks present in this region are characteristic specific kind of bonds are this. Using this function group region, it can be used to identify whether the specific functional group is present or absent. Means to determine the functional group present in that molecule or organic sample, this functional group is very useful. Means all the functional group of organic molecules which are coming under this range. The second one is fingerprint region. Means the fingerprint region range is in between 1450 to 500 centimeter inverse. The peaks coming under this range is called fingerprint region. This region arises from complex deformation of the molecules, and there may be a characteristic of molecular symmetry or combination of bands arising from multiple bond deformation simultaneously. Next, principle of IR spectroscopy. We already know the range of infrared spectroscopy is 4000 centimeter to 400 centimeter. And molecules are made up of atoms linked by atoms. This is general thing we already know. Means the molecule are made up of atoms linked by bonds. At ordinary temperature, organic molecules means at ordinary temperature, the atoms in molecule, the atoms in molecule are in constant state of vibration. Means the movement of atoms and the chemical bonds are constant state of vibration. Each bond having its characteristic stretching and bending frequency and being capable of absorbing light of that frequency. The vibration of two atoms joined together by a chemical bond can be compared to the vibration of two balls joined by a spring. Using this analogy, we can justify several frequencies of infrared spectrum. We can observe from the figure the two balls are joined by a spring, which is nothing but the two atoms are joined by a chemical bond. In that, the first figure stretched means the two bonds, if the bond is stretched, a restoring force pulls the two atoms together toward their equilibrium bond length. The first figure. In the second figure, if the bond is compressed, means both the bond is compressed, the restoring force pushes the two atoms apart. We can observe spring force. If means in the third figure, if the bond is stretched or compressed and then released, stretched and compressed and then released, means the atom vibrate. Atoms vibrate means the two bonds are joined by a chemical bond at equilibrium bond length at ordinary temperature. At ordinary temperature, the atoms in a molecule are in a constant state of vibration. These characteristic vibrations are called natural vibration. This vibration energy means the energy of this molecular vibration is quantized. Is quantized. Molecular vibration. Molecular vibration means the covalent bond vibrate at only certain allowed frequency. Means when the energy in the form of infrared radiation is applied to the sample, then it causes the vibration between atoms of the molecule. Only when the applied infrared frequency is equal to natural frequency of the vibration, then absorption of infrared radiation takes place and a peak is observed. Means the peak is observed is nothing but infrared spectrum. We will get the infrared spectrum. Based on that infrared spectrum, we will going to interpret the peaks which are obtained from the spectrophotometer and analyze and investigate which function group is present, which are the molecular interaction is present, what are the vibrational energy which are changing. Means when a sample is irradiated by infrared radiation, the covalent bond present in a molecule, means covalent bond present in the two atoms between the atoms, it will absorb external energy, it will absorb infrared radiation only when the applied infrared frequency is equal to natural vibrating frequency. Means the different functional group absorb characteristic frequency of IR radiation, hence gives a characteristic peak value. Therefore, infrared spectrum of chemical substance is a fingerprint of a molecule for its identification. Means the infrared identification means the next is molecular vibration. In that molecular vibration, before going to the molecular vibration, stretching stretching requires more energy than to bend it. Thus, stretching energy of the bond is greater than bending energy. And stretching absorption of a band appears at higher frequency in the infrared spectrum than the bending absorption of the same bond. Yes, correct? Yes. Means When a sample means when the infrared radiation is passed through the sample of organic compound, some of the particular frequency it will absorbed by the molecule, the natural vibration at ordinary temperature, the natural vibration is called lower energy level vibration. When we applied the infrared radiation to the sample, the lower energy vibration state it will excite it to higher energy vibration level. When when the molecule is having permanent dipole moment, means a molecule that are infrared active must undergo a change in its dipole moment when vibrating. This vibrational energy level takes place when the infrared radiation, this molecular vibration takes place when the infrared radiation is passed through that organic molecules, means which when the infrared radiation is absorbed by the molecule is absorbed by a molecule, the vibrational energy level it will excite it to higher energy level. That molecular vibration, importantly, there are two types of vibration. One is stretching vibration, second one is bending vibration. Means the stretching and bending vibration this takes place when the molecule or organic compound that are infrared active. Means infrared active molecules is a type of molecules, it must undergo change in its dipole moment when it's vibrating. The first stretching vibration is a type of vibration, is a oscillation. This type of vibration takes place along the line of bond. When this vibration, change in bond length will takes place, and it occurs at higher energy 4000 centimeter to 1250 centimeter. In this stretching vibration, there are two types. One is symmetric stretching vibration, second one is asymmetric stretching vibration. Aya spectroscopy is mainly dependent on modes of vibration of atoms in a molecule, and we can observe the molecular vibration or modes of vibration of the atoms in a molecule. The first one, stretching vibration. Stretching vibration is a type of stretching vibration is a type of vibration in which there is no change in bond angle, only change in the bond length. In that, first one is symmetric stretching. In that symmetric stretching, the two atoms are joined by, means the two atoms are moving away from the central atom or towards to the central atom. In the symmetric stretching vibration, bond length will increasing, both the bond length will increase or both the bond length will decrease. Means there is no change in bond angle. In asymmetric stretching, one of the bond is moving towards to the central atom, other atoms is away from the central atom. Means in asymmetric stretching, one of the atom bond length will decrease, other atom bond length will increase. Second one is bending vibration. In that bending vibration, there are two types. One is in plane bending vibration, the second one is out of plane bending vibration. In that bending vibration is a type of vibration in which there is change in bond angle. There is no change in bond length of the bond length of the atom between the atom in a molecule. Means in that in-plane bending vibration there are two types, scissoring and rocking. In scissoring bending vibration is a type of vibration in which the atoms connected to the central atom, the two atoms connected to the central atom is moving opposite side. Means the both the atom moves opposite direction. Means we already known the working of scissor. For example, two fingers moving opposite direction. The second one is rocking vibration. Rocking in plane bending vibration is a type of vibration in which the two atoms connected to the central atom, the two atoms are moves to the same direction, one direction. Here there is no change in the bond length, only change in the bond angle. The second one is out of plane bending vibration. Out of in plane bending vibration and out plane bending. In that out plane bending vibration, wagging and twisting. The positive sign indicates the positive sign indicates sorry plus sign positive sign indicates moves towards to the reader, negative sign indicates away from the reader. In wagging, the two atoms moves towards to the reader or away from the reader is wagging, out of plane bending vibration. Twisting, in the twisting, one of the atoms moves towards to the reader, other atoms moves away from the reader. Means twisting out of plane bending vibration. These are the six vibrations, stretching and bending vibrations are takes place in a molecule. Next, fundamental vibration means this molecular vibration takes place when the molecules which are having permanent dipole moment, when the molecules is vibrating. The next, fundamental vibration. Fundamental vibration is a type of vibration means to determine the degrees of freedom of a molecule. This is theoretical calculation vibration. In that, the fundamental vibration for nonlinear molecules 3n minus 5, for linear molecules 3n minus 5, for nonlinear molecules 3n minus 6. Means to determine the degrees of freedom of linear molecules, we can use 3n minus 5 formula. For nonlinear molecule, 3n minus 6 formula. N is nothing but the number of atoms in a molecule. For example, to determine the molecular vibration or fundamental vibration in carbon dioxide molecule, we already know carbon dioxide CO2 is a linear molecule. 3n minus 5. N is number of atom is 3. 3 into 3, 9 minus 5 is equal to 4. Means there are 4 fundamental vibrations are present in the carbon dioxide linear molecule. For example, benzene. Benzene is a non-linear molecule. For non-linear molecule, the fundamental vibration is 30. Means the number of atoms present in the benzene is 12. 12 into 3, 6. 6 minus 36 minus 6 is 30. Earlier, we know, earlier I have discussed the molecules which are IR active means must undergo a change in its dipole moment when it's vibrating. Means this is the selection rule of infrared spectroscopy. Means a molecule that is infrared active must undergo a change in its dipole moment when vibrating. A simplest mode of vibration that are infrared active or stretching and bending modes we already discussed. We already discussed. That have already discussed. Means selection rule of IR spectroscopy, selection rule of IR active modes means infrared active modes means molecules with a permanent dipole moment such as water, HCl, nitrogen monoxide, etc. etc. Means those molecules which are having permanent dipole moment while vibrating, those molecules are infrared active molecule. Those infrared active molecule, it will takes place the molecular vibration. If the molecule does not have the permanent dipole moment, those molecules which are infrared inactive molecule. For example, the dipole moment molecule means the HCl molecule which are having a permanent dipole moment, so it is infrared active molecule. For example, HCl, H is partially positive charge, Cl minus is partially negative charge. In that there is change in dipole moment means due to electronegative atom, it will pull the electrons towards to the chlorine. Next is the oxygen molecule which does not having a permanent dipole moment while vibrating as well as while resting. So this molecule is infrared inactive molecule. This molecule does not undergo means does not absorb infrared radiation. Infrared radiation. For simplicity, this also we are going to illustrate the vibration. We are going to illustrate the vibration modes in a linear molecule, acetylene. For example, in that acetylene, the symmetry stretching of C triple bond C will not alter the acetylene dipole moment. Means there is means no dipole moment present. Means while stretching, because the two atoms are having same molecular mass and which are symmetric, there is no change in dipole moment while stretching, while symmetry stretching. Therefore it is not a infrared active, means this C triple bond C is infrared inactive. However, substitution of either of the H atoms in acetylene produce asymmetric alkaline bond which will be absorbed, which will be IR active, means the CH asymmetric stretching of alkyne is having some dipole moment. So this CH stretching, it will absorb infrared radiation. Some other examples, for example, chlorine, hydrogen, nitrogen, these homonuclear diatomic molecule will exhibit no infrared active modes, means there is no change in dipole moment, so that these homonuclear diatomic molecules are infrared inactive. These type of molecules, it will not absorb the infrared radiation. Infrared radiation. Thank you. Thank you. If there is any doubt in this topic, we can clarify. Please contact the mail ID in nanjundaswamigs at jssatn.ac.in. Thank you.